Okay, hi guys, I'm back. Today I'm gonna actually, instead of putting up those Tyler DeWitt videos, I'm actually gonna go through the PowerPoints myself because I couldn't find a video that was kind of the way I wanted it. So we're starting a whole new unit, and it's a unit about something called the mole. And it's a bit difficult. You've never seen it before, most likely, so I think that you guys are going to want to watch my videos, and I'm going to start to do classes online every Tuesday at 1. So we're just going to keep that kind of continually going, so then you can review with me on Tuesdays at 1, and then maybe work on the assignments after that so you can see what I've taught you. So today we're going to talk about the mole, and the first PowerPoint is will be up on on the tasks, and you'll be able to read through, and you'll talk about the history of the mole and Avogadro, who came up with the idea of this mole, and just some of the older gentlemen that went through. I'm not going to spend my time on that part because you'll be able to read it. What is a mole? Okay, the mole is a unit of chemistry, you can see right here, that serves between a bridge between the atomic world and the macroscopic world. Well, what does that mean? That means that what happened was we all know that carbon-12, the isotope carbon-12, if you can remember back when we had isotopes, it has carbon on the periodic table. You can see here is 6. So that means it has 6 protons. And it also has 6 neutrons because its mass is 12.01. So they use this carbon-12 atom to give some relative mass to elements. How much mass does an element have? Okay? So when you look at this, it says carbon-12 isotope is used. So the precise definition of a mole is the amount of any substance that contains as many elementary entities as there are 12 grams of pure carbon-12. Sounds confusing. So let's talk about it a little more and see how we use this. Basically, carbon-12 and this relationship with the mole allows us to go between things like atoms and grams, which atoms are super duper 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 small, and grams are something that we use in our lab or anywhere to measure a quantity of something. So this number, the mole, allows us to talk about big amounts like grams and really, really small amounts like the number of atoms of something, like little bitty bitty atoms. So this is the mole, okay? And the mole is equal to 6.02 times 10 to the 23 atoms, molecules, formula units. I'm going to talk a little bit more about that in a second. Okay, so let's pause this for a second, and I'm going to show you something else. Okay, so if I said to you guys, this is how I always start this class when I'm in class. Oh, for this unit, you're going to need a scientific calculator. Okay, you're going to have to get a trusty calculator. It's going to need to have an exponent button. Okay, it's going to need to have an exponent button, or you might have a second function exponent, or you'll have to figure out on your calculator what the exponent button is. Okay, so I'll talk about that in a second. I'm going to start to teach you something called dimensional analysis. And what that is you do it all the time. So if I said to you, okay guys, how many dozen donuts are in 72 donuts? And I said to you guys, okay guys, how many dozen are in 72? Well, you guys know that 1 dozen is 12 donuts. So in your head, you might even be like, okay, 72 divided by 12 is 6. I'd have 6 dozen donuts. And you would just answer me that question just out. What you did in your head was you used unit, you used dimensional analysis, and you did a conversion. And I'm going to show you that right here. So what you did was you said, okay, I have 72 donuts. And you put this over 1. You always start out with what you know over 1. This is how we start dimensional analysis. And I build something called bunk beds, but you might do it a different way. I build bunk beds and I follow the unit. You guys will always hear me say in this unit, the units are more important than the numbers. Follow the unit. The unit tells the story. That's what I'm going to be doing from now till the end of June when we finish these online courses. We're going to be talking about units and how the units tell the story. Okay, so what we did in this question, we said, okay, 72 donuts is what I was given in the question, and I put it over 1. I made a bunk bed, and I'll show you a little bit in a second. And I need a conversion factor between dozens of donuts and 1 dozen and the donuts. So I know, and you know, that 12 donuts are in 1 dozen. Okay? You know that 1 dozen, a dozen donuts, is 12 donuts. So a dozen means 12. These things are equal. So we get to put them on what I call bunk beds. 1 on the top, 1 on the bottom. Why did I do it this way? Well, just like in math, once you have something on the top and something on the bottom, you get to cancel those units. So now I'm left with this. So what happens is you multiply the top and you multiply the bottom and you get a number. So I'm left with 72 times 1 dozen, 72 dozen, over 1 times 12 is 12. 72 divided by 12 is 6, and the unit gets left 6 dozen, which is what you did in your head when I said, hey guys, how many dozen donuts are there in 72 donuts? You were like, well, there's 6 dozen. This is the math behind that. Okay? Hard, I know. I understand that this isn't easy. This also can look like this. Some kids like to do it like this. Let's do the next one. How many days are in 17 years? If I asked you guys that, you'd say, well, 17 years, this is what you would do, and you'd go 17 years times 365 days, and you'd go 6,205 days. That's what you would tell me. You would all do that. What you didn't realize you were doing was dimensional analysis. So let's look at what you did do written out like this, because the numbers are going to get harder. So let's look. I said, okay, guys, 17 years. That's what I gave you. And I said, how many days are there? And you were like, you did it on the calculator, times 365. So what happens now is I say 17 years over 1. Instead of doing bunk beds, if you don't like my bunk bed, you can put times like this. So what is the conversion factor between years and days? That is going to be important. That's the second fraction that we put here. Years has to go on the bottom because I'm trying to cancel years and years. So I put 1 year on the bottom is how many days? 365 days. So what happens here? You get to cancel the unit year because there's 1 on the top and 1 on the bottom. They get to cancel. That's a math law. So now you get to do exactly what you did on the calculator. You put in 17 times 365, which was 6,205 days. Days is the only unit left. You got this answer right without seeing in your head maybe that you did this dimensional analysis. So now what's happening is this dimensional analysis part becomes more important than the number part. The units will follow through, will become more important than just being able to get the right answer. Okay? So this is what we're going to learn, but we're learning it with the mole, which is a little bit harder. So those were some easy examples. We're going to look at what they did here back to our PowerPoint. So 1 mole is equal to 6.02 times 10 to the 23 atoms, molecules, formula units. I'm going to write that down. I'm going to have a little cheat sheet. And I'm going to show you guys some conversion factors. That's what we call them. 1 mole is equal to 6.02 times 10 to the 23 atoms. 1 mole is equal to 6.02 times 10 to the 23 formula units. 1 mole is equal to 6.02 times 10 to the 23 molecules. 1 mole is equal to 6.02 times 10 to the 23 donuts. It doesn't matter what I list. I could say donuts, I could say apples, I could say pieces of bubble gum. It doesn't matter. 1 mole is 6.02 times 10 to the 23 of whatever that thing is. Atoms, formula units, molecules, donuts. Okay? It's just like saying 1 year is 365 days. 1 dozen is 12 donuts or apples or whatever. A dozen apples, dozen oranges, whatever you're talking about. And so these are things called these are things called conversion factors. They're the same thing. 1 year is equal to 365 days. So I'm allowed to do this. 1 year is equal to 365 days in a fraction. It's like saying it's 1 over 1 because they're the same thing. 1 year is 365 days. I can also write it like this. 365 days is the same as 1 year. This is correct in math because they are the same thing. I'm allowed to put them in a fraction like that, meaning it's 1 over 1 because they're the same thing. This is how I change units from years to days or days to years. This is going to become important. So I'm going to leave this I'm going to fold this, and I'm going to leave these little moles right in front of us as a cheat sheet so we can all see it. I'll bring it back into frame in a second. So let's look at the first example they did. The first example, they said, okay, you've learned some history. You'll go back and read this, and you'll watch the video links, and you'll learn a little bit more of the history of it. I'm going to show you the math. Here's an example they did. Let's do this together so that we can see it, because otherwise I don't know that you'll get it without me trying. So they said, how many atoms are in 1.22 moles of a sample of sodium? That sounds scary. Let's look at it. So what was given in the question? K stands for what we know, and U stands for the unknown. Known, unknown. So what was given in the question? 1.22 moles of sodium. Do you see that? 1.22 moles of a sample of sodium. So I know I have that. So what's my known? 1.22 moles of sodium, Na. They gave me that. And they asked me, what do I want to know? What's my unknown, or my question is, how many atoms are there? Atoms of sodium. That's my question. That's what they asked me. And they gave me this. All right. It's not a lot different than when I said to you, I've got 72 donuts. How many dozen donuts do I have? Same thing. It's just a conversion factor you're not used to using. So let's look. 1.22 moles. I'm going to set up my bunk beds or my brackets. 1.22 moles of sodium. All right. I always do bunk beds. Okay. You put that over 1. Every time what you know in the question goes over 1. That's how you start the question every single time. So what I have to do is I have to find a conversion factor that has moles and atoms. Well, let's look. This first one that we wrote down, 1 mole, is equal to 6.02 times 10 to the 23 atoms. All right, that's the one we have to use. Okay, so I'm using this conversion factor. 1 mole is equal to 6.02 times 10 to the 23 atoms. Okay, that's the conversion factor. That's what's going on this bunk bed. One goes on the top and one goes on the bottom of this bunk bed, but I don't know who goes where. How do I know that? Well, what unit am I trying to get rid of? I'm trying to get rid of moles. So what I'm trying to get rid of goes on the top and the bottom. So I'm going to write 1 mole here. And on the top of the bunk goes 6.02 times 10 to the 23 atoms. And close my bunk bed. So what happened? Atoms of sodium, moles of sodium. It wouldn't matter what element we were talking about. It's the same thing. It's standard across the board. It's like saying 1 dozen. We all know it could be 12 apples, 12 oranges, 12 donuts, 12 rolls. Well, a mole, it doesn't matter if it's a mole of sodium, a mole of calcium, a mole of anything. It's 6.02 times 10 to the 23 atoms of whatever you're talking about. It's like saying a dozen is 12 of whatever you're talking about. So it's the same kind of number. It's just a general number that applies to all things. Okay? So what happened in our little bunk bed here is I got to say, all right, a mole of sodium, that unit gets to cancel with this unit. So now I just do the math. I multiply the top bunks and I divide the bottom bunks. So let's see. On my calculator, I go 1.22 times 6.02 exponent 23. It gave me 7.34 times 10 to the 23 atoms of sodium. And that's the right answer. So, a couple things about this. When you're doing your calculator, a lot of kids want to do this. 6.02 times 10 exponent 23. That is wrong. When you push the button 6.02, when you push exponent, whatever it looks like on your calculator, when you push that, that means times 10 to whatever power you're putting in. In this case, it's 23. So you don't go, I'm going to clear it off, you don't go 6.02 times 10 exponent 23. You've added an extra times 10. Don't do that. So how you put it in your calculator is you go 1.22 times 6.02 exponent 23 equals. In my calculator, it shows up as the little number up here. Some of you have calculators where it shows the same size, but it's a space. So I can't see all your calculators, but this reads 7.34444. So you can just use 3 numbers, 7.34 times 10 to this number, which is times 10 to the 23 in this case. Okay? So this is the right answer. If you prefer to write it like this, 1.22 moles of sodium over 1 times 6.02 times 10 to the 23 atoms of sodium over 1 mole of sodium. If you like it like this instead of building the bunk beds like me, that's fine. It doesn't matter. Moles of sodium, it's the same thing. This times this, divided by 1, divided by 1. You don't have to do that. Is 7.34 times 10 to the 23 atoms of sodium. Okay? So this is challenging stuff. They gave us another example I'm going to show you. I know this is a long video, but I think you're going to be thankful for it when you try to do these assignments. Okay, here's the next example on the slide that they gave us. How many moles are equal to 4.79 times 10 to the 24 molecules of carbon monoxide? Ooh, sounds scary. Let's see. What do they give us in the question? What is known? 4.79 times 10 to the 24 molecules of CO. They gave us that. What are they asking us? What's our unknown? How many moles? Moles of CO. We're talking about carbon monoxide here. So this is what we know, and this is what we're asked. Now we need to find a conversion factor between moles and molecules. So let's look at our little sheet that I wrote down earlier. Okay, I see something here. 1 mole is 6.02 times 10 to the 23 molecules. So I'm going to write that conversion factor down for us here. 1 mole is equal to 6.02 times 10 to the 23 molecules. I would like you guys to write this sheet down, pause the video, and write down these things. If we were in the classroom, I would have written these on the board, and I would have left it up there, because as we go through these units, I'm going to continue to add these conversion factors, and then we're going to have this cheat sheet up on the board at all times so you can look up and see which conversion you need to use. So write this down and keep it with you. From now till June, we're going to be using these conversion factors. Unfortunately, guys, this is not going to go away. So if you think, oh, well, next unit will look different, well, the next unit will, but then we're back to this again. So this is, if you don't get this, then you call me for one-on-ones, log into my weekly classes, because this isn't going to go away, okay? So just know that. You're going to have to understand it in order to get the credit. All right, back to our question. So our conversion factor we saw between moles and molecules. Okay, we've got it. So what do? How do we start this off? We start with what we know and we put it over 1. 4.79 times 10 to the 24 molecules of CO over 1. That's what we do. You can build a bunk bed, or you can just put the times, whatever you want. I'll put the times this time so you see. I have to use this conversion factor to get me from molecules to moles. How do I know which goes on the top bunk and which goes on the bottom? I want to get rid of molecules. I want to be able to cancel it out. So I have to put it on the bottom, because then it can cancel top and bottom like in a fraction. Okay? If I put it on the top, we'd have molecules squared. Molecules times molecules. That wouldn't work. So I have to put molecules on the bottom. So I'm going to put 6.02 times 10 to the 23 molecules of CO, because it doesn't matter what I'm talking about, right? Doesn't matter what element. This is the truth. No matter what element, is equal to 1 mole of CO. All right? This is my formula. This is what I get to do in math. I get to cancel out molecules of CO, molecules of CO. I get to cancel those out. So the only unit left is moles of CO, which is what it asked me for. So we're on the right track. We just need to do this on the calculator. I'm going to show you how I would do it on mine. I'm going to hold this up close. I got to kind of tilt it. Hopefully you guys can see it. Okay, so 4.79 exponent 24. And since this is on the bottom, okay, so I would multiply the whole top. So 4 times 1. I can do that, but it's going to just be the same. I hit equals. This one, again, 1 times the bottom. It's just, this is just this number. So 1 times anything is itself. So let's divide by this. I'm going to hit divided by 6.02 exponent 23. That's how you put it in. I hit equals, and I get 7.95. I got to round that up, 7.96. So that it equals to 7.96 moles of CO. 7.96 moles of CO. How did I know what the unit was? This is the only unit left. The other guys got canceled out. And as you can see on the sheet, 7.96 moles of CO, that's the right answer. So we are correct. Okay. So that is the first video explaining this first day's worth of work. There is a practice sheet. I'm going to stop this video and then let you guys take a breather. And then I'm going to do a few examples from the practice sheet as well, just helping you out because this stuff is hard. I'm going to show you a few more things. But for now, that was the first PowerPoint. Go through, read about the old guys, read about how they figured out Avogadro's number, all of that. Watch the video links, and then get to some of the math, okay? All right, take care. We'll be on a video soon. Bye-bye.